Hello, today we are going to talk about third-degree equations, and to be specific, we will prove what is known as the del Ferro formula, which gives one of the solutions of the so-called depressed cubic, called that way because we don't have x squared in the equation, as we can clearly see. The formula is the following. And our aim is how to derive it. Subscribe to the channel, and let's start. We begin with something simple, u minus v cubed, and we will simply expand it. We will move this part to the left-hand side, which gives us the following expression. And we'll write the following way. Good. Now we bring back our original equation, and we notice that if we put x is equal to u minus v, there are some striking similarities, and by way of simple comparison, we get the following system of equations. So x is gonna equal u minus v, p is equal 3uv, and q is going to be u cubed minus v cubed. Our aim is to find x, which is equivalent to finding u and v. So we need to express u and v using p and q, which are the coefficients of our equation. We can see that from the second equation, we can write u in the following way, which will give us that u cubed is p cubed divided by 27 v cubed. Now we plug that in the third equation, and we get this expression, which in turn will give us a second-degree equation in v cubed. So we can see v cubed squared plus u v cubed. And we know how to solve this equation. It's a second-degree equation. And from the third equation, well, we get u cubed equals q plus v cubed, and we will find this expression. Now, using the first equation, we can express x using u and v that we found. And after some simple changes, we get our desired result. Let's use our result to find the so-called plastic ratio, which is the only real solution for the third-degree equation on screen. After rewriting our equation in our standard form, we get p is equal to -1 and q is equal to 1. After plugging that into our solution formula, we get this value. I will leave some links in the description to read more about all of this. I hope the presentation was clear. Like and subscribe, until the next time.